Section 2.2 discusses trig functions of non-acute angles. So we're moving into broaden our horizons with those trig functions, thinking about triangles one more time. Our goal actually today is to identify exact trig values for angles larger than 90, but this particular video is going to discuss the idea of reference angles. Now, associated with every non-quadrantal angle in standard position is a positive acute angle known as a reference angle. If our regular angle is denoted by theta, then our reference angle is denoted by what we would call theta prime. And we're going to consider looking at our quadrants where theta is larger than 90. We're going to look at how to find theta prime. So in the first example, where theta is in quadrant 2, notice that if we're looking for theta prime here, well, this amount out here is 180. This is 0. We've got our 90-degree mark and our 270. So in order to find theta prime, we would actually take the 180 degrees and subtract off the given angle theta. And that's going to find our theta prime in the event that we are in quadrant 2. Looking at the next drawing, where we see that we have theta moving all the way into quadrant 3, if we want to find our theta prime in this case, we're going to have to take the 180 degrees, take theta first and subtract off the 180 degrees to get this little bit of portion in here between those two amounts. And then in the last drawing where our angle goes all the way into quadrant 4, to find theta prime, we're going to take the 360 degrees and subtract off theta. I'm sorry it's squishing that up right there. Something to do with that drawing board, but that's what it is. So it would be 360 degrees minus theta. Now guys, we've got these drawn as just angles in standard position, but remember that I can, with an actual reference angle, draw a triangle. And when I draw that triangle, I always draw back to the x-axis. So for example, in the first one, if I wanted to draw a triangle associated with that angle, I could draw it just like that. For this one, if I wanted to draw an angle associated with this, I would again draw it back to the x-axis. So there would be a triangle associated with that particular reference angle. Again, this reference angle gives us the triangle dropping back to the x-axis right in here. So never, ever, ever reference back to your y-axis. We're always referencing back to the x-axis, and that is why the 180 and the 360 crop up when we are calculating for theta prime. In the next little bit of sections that we're going to look at examples for finding reference angles, because that's going to be key to moving on in this section. Alright, so we want to find the reference angle for the following angles. The first thing I'm going to do typically is draw it. I want to see where it's located. And I always remind myself that 0 starts it, 90's at the top, 180 straight out, 270 straight down, and then back to 360. So I can very quickly realize that 218 has got to be somewhere, I don't know where, but it's somewhere in this third quadrant because I know it's between 180 and 270. So in order to find theta prime, my rule says that I take theta, which is 218 degrees, this is theta, and I subtract off my 180 degrees. So in this case, I'm going to write above it, sorry about that sloppiness, that would give me theta being 38 degrees. Theta prime, my reference angle, is 38 degrees. So this one is 38 right here, and if I wanted to draw a triangle related to that and look at sine, cosine, and tangent, I could. We'll talk about that a little more later. Okay, in my second reference angle, again, the first thing I do is draw it. So I've got 0, 90, 180, 270, 360. I'm going to hit that zone over there again. And I can see very clearly that 145 is going to be somewhere in my second quadrant because that is between 90 and 180. So to find theta prime, I'm going to take my 180 degrees and subtract off my theta, which is 145 degrees. That was given to me. And so theta is going to be 35 degrees. This angle here, which is theta prime, is 35 degrees. And I could draw a triangle associated with that back to the x-axis. Okay. So those are ways we find reference angles. Going back to page 1 for just a minute, remember if you're in quadrant 2, this is your formula. If you're in quadrant 3, this is your formula. And lastly, if you're in quadrant 4, this is your formula. What about quadrant 1? Well, the reference angle and the angle itself are the same when it comes to quadrant 1 because quadrant 1 is already an angle that's acute. Okay. Now sometimes we aren't even in the zone to find a reference angle. Sometimes we have to do a little bit of work before we can start finding a reference angle. And that is because when you go to find a reference angle, you need to start between 0 and 360 to begin with. And sometimes you're not there. Consider the following problem where you're looking for a reference angle for 1387 or 1387 degrees. That's not between 0 and 360. So we're going to bring back the concept of coterminal angles. Hopefully you mastered that in the last chapter. And this will be nothing for you, but we've got to find a coterminal angle first. Coterminal angles, we want one particularly in between 0 and 360. So I'm going to come over to the side. Remember for coterminal, you subtract off 360 if it's really big and positive, and you add 360 if it's negative, till you get to something where you need it to be. So I'm going to subtract off. That gives me 1027. So that's still not between 0 and 360. I'm going to subtract off again. I'm going to do a little borrowing here, do my mathematics. Alright, still not between 0 and 360, so I'm going to subtract off again. Alright, now this little guy right here fits the zone. He is between 0 and 360 degrees. This is a coterminal angle with 1387 degrees. Now, what I want to do is find a reference angle. So going back, the first thing I'm going to do is draw it. You do not have to label these little marks all the time. I like to keep us in mind of where we are. 307 degrees is what I'm wanting to draw right now. And so I know that it has got to be somewhere in quadrant 4 because it's between 270 and 360. And my reference angle would be here. If I drew that triangle off, according to the x-axis, it would look like this. And the rule is for theta prime, or the reference angle, I would take 360 degrees and subtract off my angle of 370 degrees, which is theta. And theta prime would be 53 degrees if I haven't done anything crazy. So this little angle in here would be 53 degrees. Okay, hopefully that is enough to get you balanced on reference angles. We're going to do 3 more problems to make sure it's all sealing with you well. That way we can move on to what we really want to do in this section, which is find trig values of all kinds of different angles that are bigger than 90 degrees. But we're going to start here, and we're going to make sure we've got reference angles quite in our heads before we continue. So want to find the reference angle for the following. Problem number 1. The first question to ask yourself, is theta between 0 and 360 degrees? And the answer is no, it's not. It's negative. So first we have to do is find a coterminal between those angles. So this is a negative 135 degrees. To find coterminal, I'm going to add 360 degrees. So I got to think about that. I would actually have to flip that upside down to figure out that. Let's see. Give me 5 seconds to scratch this on paper. This shouldn't be difficult, but working on the fly there, I sometimes don't pull it off too well. Alright, so that should be 225 degrees. Is this angle between 0 and 360? Yes. So this is my coterminal angle. that's in the right zone. That was step number 1. Step number 2, draw it. That is my recommendation. Draw it. Alright, I've got 0, 90, 180, 270, 360. This is 225. So ideally you're going to put it between 180 and 270. You're going to have it working out there in the third quadrant. This is 225 degrees. The reference angle itself is this angle right here, theta prime, and we can make a right triangle with that if we want to, and look at it there. Once you've found the first one and the second one, the third thing you do is you're going to calculate theta prime. So let's see. To find theta prime, we're going to take theta, which is 225 degrees, and we're going to subtract off our 180 degrees because that's what our formula tells us to do when we are in quadrant 3. So that would be 45 degrees is our reference angle here. This would be 45 degrees. Now this is actually a good one to think about. We can find trig values for this because we know what a 45, 45, 90 should actually look at. We can find ratios for their sides and go from there. But we'll do that soon. Alright, going back to the next problem. 480 degrees. Is it between 0 and 360? No. So first step is I take my 480 degrees. In this case, I'm subtracting off 360 to find something coterminal with it that works between 0 and 360. Is 120 between 0 and 360? Yes. So this is my coterminal angle without any trouble. Second step, draw that coterminal angle. 0, 90, 180. I'm going to stop because 120 is between 90 and 180. It's somewhere over in quadrant 2. My actual angle, theta prime, the reference angles I'm looking at, forms that triangle with the x-axis 90 degrees. And to find theta prime, I would take 180 degrees and subtract off my given angle, which is actually a coterminal, 120. And so theta prime would be 60 degrees. Something else we know about, 60 degrees. So this is a 30, 60, 90. And we could talk about those ratios as we went on. But you get the idea. Okay, last one, and this is just meat point, but I wanted to mention it. 87 degrees. Is it between 0 and 360? Yes. So let's just draw it. 0. Ooh, I can't draw it over there. It's too close to the edge and the computer acts crazy. I'm going to scoot it in here. So I've got 0, 90, 180, 270, and then of course 360. This is between 0 and 90. It's already in quadrant 1. So again, your theta prime is the same thing as theta in quadrant 1. So our theta prime is 87 degrees. It's its own reference angle. Sounds kind of southern. It's its own reference angle. Theta prime is there. So then there's no work to do. We're good with that. Okay, that thoroughly covers the topic of reference angles. In the next part of section 2.2, we will look at implementing this knowledge to find actual trig values of angles that are bigger than 90 degrees.